Hey there, science fans! Today, we're diving into the exciting world of batteries, those little powerhouses that keep our gadgets running. Ever wondered what makes a battery tick? Let's break it down. First up, we've got energy density. Think of it like a battery's fuel tank. A higher energy density means more energy packed into the same size, like a sports car with a bigger gas tank. Then there's charge-discharge efficiency. Imagine pouring juice from one container to another. You always lose a little bit, right? Batteries are similar. They lose some energy when charging and discharging. Efficiency measures how much energy we actually get to use. Finally, we have cycle life, which is like a battery's lifespan. Each time you charge and discharge a battery, it's like taking it for a spin. Over time, the battery gets tired and it can't hold as much charge. Cycle life tells us how many charges a battery can handle before it needs to be replaced. Now, we don't want our batteries conking out too soon, do we? That's where some cool math comes in. Get ready for a dose of mathematical magic. Meet E, also known as Euler's number, a special value approximately equal to 2.718. Now, I know what you're thinking. What's so special about this E thing? Well, E has this amazing property where it helps us understand how things change over time, like the way batteries charge and discharge. Here's the cool part. E is involved in something called exponential functions. These functions help us model how things grow or decay rapidly, kind of like how bacteria multiply or how radioactive materials decay. And guess what? Battery behavior can be described using these exponential functions too. But before we dive into that, let's talk about normalization. Imagine you're comparing the heights of a giraffe and a mouse. It's easier to compare them if we use a common scale, right? Normalization is like finding that common scale for our battery data. It helps us make sense of the numbers and compare different batteries fairly. Now that we've got E and normalization under our belts, let's see how they can help us unlock the secrets of battery performance. Remember those exponential functions we talked about? Well, they're the key to understanding how batteries behave over time. See, the way a battery charges and discharges isn't linear. It doesn't charge at a steady pace like filling a bucket with water. Instead, it follows a curve, much like the swoosh of a roller coaster. This curve can be described using, you guessed it, exponential functions involving our friend E. These functions help us predict how much charge a battery will hold at a given time, or how long it will take to charge to a certain level. By using exponential functions to model battery behavior, we can gain valuable insights into how different factors, like temperature or usage patterns, affect battery performance. This knowledge is super important for designing longer-lasting, more efficient batteries. Now hold on tight, because things are about to get even more electrifying. In the next section, we'll explore how to use these exponential functions to actually optimize battery performance. Section 4, Unleashing the Power of Math. Optimizing battery performance. Hold on to your hats, science enthusiasts, because this is where the real magic happens. Using the power of E and those cool exponential functions, we can tweak and optimize how batteries perform. It's like fine-tuning a race car for the best speed and efficiency. Imagine this. We can use these mathematical models to find the sweet spot for charging and discharging rates. By finding that perfect balance, we can make our batteries last longer and store more energy. It's like getting a free upgrade for your phone battery, just with math. But wait, there's more. These mathematical models can also help us understand how temperature affects battery life. We can use this knowledge to design batteries that perform well in extreme conditions, from the freezing cold to the scorching heat. Imagine having a phone that doesn't die in the middle of winter or overheat on a hot summer day. By using the power of math and our friend E, we're not just understanding batteries better, we're making them smarter, stronger, and longer lasting. It's like giving them a superpower boost. Section 5, a step-by-step guide, implementing Euler's number for better batteries. Ready to roll up your sleeves and put E to work? Here's a simple guide to using Euler's number for awesome battery optimization. Don't worry, it's easier than you think. Step 1. Gather data. First, we need information. Think of it like taking your battery's pulse. We need to measure things like charging, discharging rates, voltage, and temperature over time. This data will be our secret ingredient. Step 2. Normalize it. Remember how we talked about comparing a giraffe and a mouse? We need to normalize our battery data to make sure we're comparing apples to apples, not apples to oranges. Step 3. Model the magic. Now for the fun part, using our normalized data, we can create those cool exponential functions that describe our battery's behavior. Think of it like creating a custom-fit suit for our battery. Step 4. Test and tweak. No scientist worth their salt stops at just one experiment. We need to test our model, tweak it, and test it again. It's all about finding the perfect recipe for battery awesomeness. And there you have it. With these simple steps, you can use the power of E to unlock your battery's full potential. It's like having a secret code to unlock a treasure chest of battery power. Section 6. Euler in the real world. Practical examples of battery optimization. Okay, science fans, time to see how E is changing the battery game in the real world. From our phones and laptops to electric cars and even renewable energy storage, E is making a big impact. Imagine this: electric cars that can drive farther on a single charge thanks to optimized battery management systems. Or how about solar panels that store more energy for use at night, all thanks to E working its magic behind the scenes. And it's not just about making things last longer, it's about making them safer too. By understanding how batteries behave, we can design systems that prevent overheating and other hazards, keeping our gadgets and ourselves safe. So there you have it. Euler's number, that mysterious E, is quietly powering our world, making our batteries better, stronger and safer. And who knows what other amazing things E will help us achieve in the future. The possibilities are as limitless as the power of math itself.